Hello and welcome to our lesson on solving linear inequalities. Today we will focus on two main objectives. First, understanding how to solve linear inequalities. Secondly, representing these inequalities on a number line. After we master these objectives, we will work through some examples to apply our new knowledge and solidify our understanding. Before we begin, let's recap what you've learned so far. You should be familiar with algebraic vocabulary, allowing you to comfortably discuss variables, expressions, and equations. With this foundation in place, we're ready to introduce new mathematical techniques. Solving linear inequalities and representing them on a number line is crucial for various mathematical and real-world problems. For instance, imagine you are planning an event with a budget of no more than £500. Using inequalities, you can easily express this condition as an inequality such as spending £500 and visually depict the possible spending amounts on a number line. So let's get started. First, let's quickly recap what an inequality is. An inequality is a mathematical statement that compares two expressions and shows that they are not necessarily equal. There are four different symbols we use for inequalities. Let's take a look at them. We have the less than symbol, the greater than symbol, the less than or equal to symbol. Finally, we have the greater than or equal to symbol. Great. Now let's move on to solving a linear inequality. Solving a linear inequality is similar to solving a linear equation. However, instead of an equal sign, we use one of the inequality symbols. The goal is to isolate the variable on one side of the inequality. For example, consider the inequality. 3x plus 2 is less than 11. To solve it, we follow these steps. First, subtract 2 from both sides, leaving us with 3x is less than 9. Then divide both sides by 3, which gives us x is less than 3, so the solution is x is less than 3. One important difference to note when dealing with inequalities as opposed to equations is that if you multiply or divide by a negative number, you have to flip the sign of the inequality. To see an example of why this is necessary, consider the inequality 2 is less than 4, which is obviously true. Multiplying both sides by -1 gives us -2 is less than -4 if we do not flip the sign. But we know this is not the case since -2 is actually greater than -4. Similarly, if we divide that inequality by -2, we get -1 is less than -2 if we do not flip the sign, which again is clearly not true. It should be -1 is greater than -2. Always take care when multiplying or dividing inequalities by negative numbers. Now that we have solved an inequality, we need to represent its solution on a number line. Here are the steps for this. We draw a line through the numbers that satisfy the inequality. To distinguish between our different types of inequalities, we have different ways to denote whether to include an endpoint of the line or not. We use an unshaded, also called open circle on the number line to indicate that a number is not included in the solution. This is used for the less than and greater than symbols. We use a shaded, also called closed circle, to indicate that a number is included in the solution. This is used for the less than or equal to and greater than or equal to symbols. To help you remember this, think of the shaded circle as coloring in the number because we are including it in the inequality. Let's take the example we solved above, x is less than 3, and represent it on the number line. Since x is less than 3 and 3 is not included, we use an open circle at 3 and shade to the left. Now let's consider an inequality using a closed circle. For example, solve and represent x is less than or equal to 2 on a number line. To plot this on the number line, we put a closed circle at 2 and shade to the left. By visualizing inequalities with open and closed circles, you can clearly see the set of possible solutions on the number line. Understanding linear inequalities is foundational and will prepare us for more complex topics such as solving quadratic inequalities, which we will explore in future lessons. With these concepts in mind, let's proceed to some practice problems to consolidate our understanding. Consider the inequality. 2x plus 3 is less than 7. We want to isolate the variable x and then plot this on a number line. Here's a step-by-step solution. First, subtract 3 from both sides of the inequality, leaving us with 2x is less than 4. Next, divide both sides by 2, which simplifies to x is less than 2. Now we need to represent this on a number line. First, draw a number line, mark the point 2 on it. Since x is less than 2, not less than or equal to, we use an open circle at 2. Finally, shade the number line to the left of 2 to show all numbers less than 2. Now let's try another example. Consider the inequality. Minus 3x plus 4 is less than or equal to 10. Here's step-by-step solution to isolate x and plot this on a number line. First, subtract 4 from both sides of the inequality. This simplifies to minus 3x is less than or equal to 6. Next, divide both sides by minus 3. Remember, dividing by a negative number reverses the inequality sign. So we are left with x is greater than or equal to minus 2. Now we need to represent this on a number line. Start by drawing a number line and marking the point minus 2 on it. Since x is greater than or equal to minus 2, we use a closed circle at minus 2. Finally, shade the number line to the right of minus 2 to show all numbers greater than or equal to minus 2. Let's now consider a more difficult example of a compound inequality. Here's a step-by-step solution. We solve each part of the compound inequality separately. So let's start with the left part. 1 is less than 2x minus 1. Add 1 to both sides. This simplifies to 2 is less than 2x. Then divide both sides by 2. This simplifies to 1 is less than x. Next, we solve the right part. 2x minus 1 is less than or equal to 5. Add 1 to both sides. Then divide both sides by 2, leaving us with x is less than or equal to 3. Then we combine the results. From the two parts, we have 1 is less than x and less than or equal to 3. Finally, we need to represent this on a number line. Draw a number line, mark the points 1 and 3. Since x is greater than 1, use an open circle at 1, and since x is less than or equal to 3, use a closed circle at 3. Shade the number line between 1 and 3 to show all numbers greater than 1 and less than or equal to 3. With these examples, you should now have a clearer understanding of how to solve linear inequalities and represent them on a number line. Make sure to continue practicing this with more exercises to reinforce these concepts. In today's lesson, we explored the concept of solving linear inequalities and representing them on a number line. We began with a quick recap of inequalities, revisiting the symbols used to express them: less than, greater than, less than or equal to, and greater than or equal to. We then moved on to solving linear inequalities, demonstrating the process with an example. Next, we discussed how to represent these solutions on a number line. We introduced the use of open circles for inequalities that do not include the boundary number, less than and greater than, and closed circles for those that do, less than or equal to and greater than or equal to. This foundational knowledge prepares us for more advanced topics in algebra and beyond. Watch the rest of the GCSE Maths course at Sophos Education.